So let's start. I have some slides to cover. So good morning and welcome to my talk about the Oracle MLE. I'm happy to see at least some of you here. It's easy to speak without being alone. So my name is Philipp Salvesberg. I work for Trevadis and I'm focusing on database-centric development since 1988. So that's a long time, so I have some experience with data modeling. I obviously have some experience with SQL, with PLSQL, and I have also a lot of experience with Java. But to be honest, I have almost no experience with JavaScript and Python. So I will talk about JavaScript and Python, those are demos, and you have to be skeptical. And I guess there are some of you who knows how JavaScript works, so pay attention. Okay, that's the agenda. After a general introduction into the topic, I will talk about what the GraalVM is, and then I will show you and explain what we have in the current version of the MLE. And then I go into the future and guess when I expect the production version and what will be in. And I will also think about the long-term heading. Where are we heading to with the MLE? So that's when it becomes a bit speculative. I'm talking about version 30. It could be 32. It could be 29. Doesn't really matter. It's just a long time in the future where we are heading to. And why am I doing this talk? It's a talk about a feature which does not exist, it's experimental, because I'm convinced that this MLE has the potential to become the next big thing in the Oracle database since Oracle version 7. And you know what was introduced in Oracle version 7? That was PL/SQL, and that was the cost-based optimizer. So I say it has the potential. It depends on many things. But let's get started. So the first thing I want to talk about is code in the database. So consider this simple example. I have a GUI. I want to visualize data from a big database on the client side in a chart, in a simple donut chart showing some information, let's say about the turnover over a year or quarter. It doesn't just matter. So when we think about how to solve that, we have to think about, at a certain point, how many number of requests I do against the database and how many data I get back. In other words, I'm thinking about whether I'm going to push code to the database or I'm push data to the code. And why is that so important? Because this number of requests, these are network round trips. And network round trips are not that fast. In fact, you could be happy if such a round trip takes about a single dot millisecond, so something between 1 and 9 milliseconds. So this sounds fast, but when you do it a lot of times, let's say 1,000 times, then we are not talking about milliseconds, we are talking about seconds. And then it becomes slow. Waiting for such a chart for 10 seconds is just not an option. So we have to think about that. In this scenario, it's really easy. So we are on Apex conference and you are thinking, hey, what is this guy talking about? But in reality, it's not that easy. So in this case, we just ask the database, hey, give me all that data for that region, make a summary, group by the region. It could be selected from various tables. And the database does the processing. The database knows how to do that and gets an optimal plan and gets me the result back. In that case, the result is very small. It's just a couple of rows. In that case, 3 rows are enough, and I get that back in a single TCP/IP package. That's the essence of pushing code to the database. And that's what PinkDB or SmartDB is about. It doesn't matter if it's based on a view, if it's within a package, it's good when the processing is done in a database. So what languages do we have to do that processing? I mentioned SQL in the example before. I mentioned PL SQL, but there is also more. We have XSLT to transform XML to various target results, PDF or whatever. Or we have XQuery. These are languages where just a connection to the database is enough. But there is more. There are also the possibilities since the beginning of Oracle to write your own C modules. But that's a bit complicated and really a pain to develop because you need access to the database on the OS. You have to compile it there, to link it there at least. And the development process is cumbersome, and the deployment also. You have another option. You have Java since a long time in the database. You can do everything from the client. You need a small CLI, load Java to load the jar into the database. But again, this is also very slow, has a lot of issues. So when I load a jar into the database from a command line perspective, this is easy. Behind the scene, there will be an unzip. Every single object, every single file in the jar will become an object in the database. So with a lot of dependency, you easily end up waiting 30, 45 minutes to complete the process. So it's not that simple in reality often. Of course, there are simple cases where you just rely on the JDK, and then you may need just a connection to the database is enough. But what happens if you have a problem and the solution for the problem already exists in JavaScript? JavaScript is the most popular language nowadays. So I may find a solution on the internet and I'd say, hey, I would like to use it in my database. It matches 100%. So I have basically two options. I may rewrite it to one of these languages, PL SQL, C or Java, or I may say, that's too much work, that's error-prone, cumbersome, I have to deal with the upgrades of that package. Hey, I install it somewhere else on an application server, and it's not that much of data I need to gather. And in that case, you're just putting the code somewhere else. So these are things that happen, from my point of view, more often. It's not, in reality, you have to just get things done. And if it's not easy to put code in the database, you don't do it. So that brings us to the GraalVM. What is the GraalVM? GraalVM has basically three important properties. First of all, it's polyglot. That just means every language on the world may run on the GraalVM, technically. In reality, not everything is implemented, but there are no restrictions. Everything can run on the GraalVM. It's embeddable. The topic of this talk is the Oracle database, so embeddable in the Oracle database, but it's not limited on the Oracle database only. It works also in MySQL, and it works also on an HTTP server. So why would I want to have an MLE in the HTTP server? So, for example, you have complex routing rules, and you would like to define them in Python, because you like Python instead of everything in a regex. So therefore, you could write these routing rules in Python. So there are various use cases you can think of. And a very important property is the efficiency. The stuff is really fast. So it's fast for standalone Java applications. Think about you want to have a command line interface you write. And if you write a command line interface based on a Java, it's no way that it starts up faster than 200 milliseconds. We have the just-in-time compilation. That's the limitation. Based on GraalVM, they have an option to create native images. Native images uses ahead-of-time compilation. Just means it compiles it at runtime. It produces the result at runtime. And then you have the ability to start up much faster. In fact, much faster means 1 millisecond. So that's 200% faster, 200 times faster. So in that case, you may use it for serverless computing. So it's essential in that area. But honestly completely not interesting when we talk about the MLE. The other option, the other thing is more important. That's the interoperability. So that's nothing new. We can already call JavaScript from Java. But what happens behind the scenes is that when you have a string in memory somewhere on Java, and I call something in JavaScript, this string has to be marshaled and then put there in the JavaScript engine, and then unmarshaled and put there in the memory. Then if you have some processing, some result, these results have to be again marshaled and transferred, and then unmarshaled on the other side. Sounds familiar? You have the same problems within Oracle with the SQL engine and PL SQL. We know that from context switch, and we know the impact. Sometimes it matters, sometimes it doesn't matter really. But that's the problem. And with the GraalVM, there's no overhead from context switch. So that's cool. So how does the architecture look today? We have the basis, the Java hotspot compiler. That's all the stuff which interacts with the OS specific. So Java is basically independent of the OS, so I don't want to care about it. So that's what the distributions care about. And then we have the next layer, that's the compiler interface. This compiler interface was private up until an early version of JDKA. And the Graal team requested a change in that because they wanted to do some fancy stuff with the Graal compiler, and they want to ensure that they are working with a public API. They requested a public API. And since Java 8, we have such an API. And then we start with the layering of the GraalVM. We have the Graal compiler, which just feels like every Java compiler you know. Same parameters, more or less, when you don't need some special options. And you may compile Java, Scala, Groovy, Kotlin, whatever. The known JVM language is based on that. So, but that's not all. That's just the JVM languages. So what a core feature of GraalVM is the Truffle framework. The Truffle framework enables me to run every other language on the top of the GraalVM. So in this case, it's JavaScript, it's Python, and others. But there is even more. You can run native languages on top of the GraalVM. This means you can run C or C++ stuff on top of the GraalVM. Of course, you have an additional layer called Zulong. There's a low-level virtual machine on top of it, and all this layering costs a bit. But when we talk about costs of the layers, we also have to look at the Truffle framework a bit closely. The Truffle framework is something which is really cool. It produces a universal AST, the universal abstract syntax tree, enhanced with some additional information on some nodes. This additional information are capable to gather runtime statistics. Sounds familiar? We have that in the database. They gather information, and they decide based on the runtime data they gather whether an algorithm A or B is better suited. For example, to sum up numbers, if I get just integers, it's a single operation on the CPU. If I get big decimals, integers, it's a complex operation. It needs something else. So you have constantly switching, everything done by the Truffle framework. So from my point of view, it's not just a layer and overhead to enable other languages, it's a performance feature. I compare it with a Formula One car. A Formula One car, I think you all know, a Formula One car has this big spoiler in the back. And the big spoiler makes it possible to run fast in the corners. But it slows you down on the straights. But if you want to win a race, you have to optimize the lap time. And you have to think about, I have to overtake somewhere and something like that. So if you want to win the race, you need a spoiler. No way to win a race without one. And that's my comparison with the spoiler is basically the Truffle framework is the spoiler of the GraalVM. So this leads to a change in the future architecture. So what I think will happen is that every language in the future will run on top of the Truffle framework, just to use these performance optimization features. That's where we are heading to. Talking about the performance, I have, in fact, grabbed a graph from Thomas Wirtlinger, produced it's a bit older than a year. It shows some performance figures. The gray bars are the best competitors in class. They are all normalized on a 1-0 level. And the red ones are the GraalVMs. The higher the bars, the better. So if you see, Java is more or less the same. Scala is 20% faster on GraalVM. You get 4x for Ruby, 4.5x for R, and it's slower on the native ones. C, plain C is faster than C based on the GraalVM. So that's not a surprise. But it's also a bit faster, about 10% on the JavaScript engine. Because the best in class there is Google V8. And Google V8 really invests a lot of money to improve the performance constantly. And it's difficult to catch up, the small Graal team to catch up with these performance improvements. But eventually they will. And when you think about overall performance and you build in a future application where you have multi-languages included, it really depends what you do. When you do a lot of stuff based on Ruby or R in your overall application, then the overall application will be much faster. So in a sense, I think you do not lose a lot of time, but you have the potential to gain a lot. So, somehow I lost the ability to click on the next slide. Okay. Good. So we have two editions for the GraalVM. One is the Community Edition, and one is the Enterprise Edition. Community Edition is free. It does not have all the features, but you see all the source code. The Enterprise Edition comes with some additional performance tricks and also additional security features. So Twitter is probably the largest customer of that one, just to gain better performance or get the same performance with less hardware. So, what do we have in version 12c, the current beta of the GraalVM in the database? So, let's quickly look at the history. We had a first version which was released before OpenWorld 2017. It was just based on JavaScript. It came on Docker, it came on VirtualBox. And a year later, we had a beta version just available in the cloud. Now we got also Python beside JSON, and with a integration into Apex. So basically, everywhere where you could write PL SQL code, you could also choose and say, I would write this block in JavaScript or in Python. And behind the scenes, in the database, there was an additional package, dbjs MLE, which is able to process that with a default connection, stuff like that. So that was just the showcase in the area of Apex. And the current version was released end of last year, and it also contains JavaScript and Python and some fixes. Very important fixes is that the UTF-8 is fully supported. Previously, we had some problems with UTF-8, just US ASCII 7-bit worked correctly, but now these problems are really solved. But it is available on Docker only. So I will look at that one. You have perfect documentation if you want to install it on your laptop. No problem at all. Just follow the instructions on the documentation. They are good. I also just copied out what I've done on my laptop. I copied down the tar file and created a container according to the documentation. That's not really fancy. And then what I also did, I installed Node.js into that container. And because it's something which you usually don't do, I also pointed out here on the slide how you do it, how do you get into a root container and add additional stuff here. But I just installed additional packages, Node.js and Browserify. I will show a bit later. And then I also installed SQL SQL is helpful because the SQL Plus was not able to deal with the new syntax, but SQL was. So that essentially helps you to deal with a new component, with new SQL components. And I also fixed some issues with the character settings. That's it. So that was the setup for my local Docker container. So let's consider a small use case where JavaScript in the database could make sense. So let's consider we are selling routers and our application is somehow able to gather feedback from the customers. Some customers are happy and give and say so in the feedback, and some customers are not that happy and say also so. So you easily, when you read the feedback, you find out what it is. But I want to do that automatically, sentiment analysis. So we have now 2019, and sentiment analysis is nothing new. Come on, when I'm a JavaScript developer, I just switch to NPM and search what are the packages I have. I have not simply one option, I probably have more. And one option you easily find is just a package which is called Sentiment. And you have a lot of information there also. You see, how many downloads I have per week. So 70,000 downloads per week sounds to be quite popular. What is the license? What are the theoretical background here, on what paper this stuff is based? How do I use it? What other dependencies am I sucking in when I download that stuff, and so on. So I get a lot of information on NPM. Based on that, I can decide, okay, that sounds reasonable, I will use it. So I decided I will use it because I know a lot about JavaScript. And then, how do we install such a package? It's really easy. If you know Yum on Linux, or apt, depending on the distribution, it's similar. You just say npm install sentiment, and it's installed and usable for your local Node.js. And then I want to run it. And then I create a JavaScript wrapper. Why do I create the JavaScript wrapper? I have a usage, how it is explained, and come to it a bit later. But what I basically do is everything what the documentation say. The first 3 lines here, or basically really the first 4 lines here, is according to the documentation. And what I'm returning is not this result directly. I'm returning it as a string. Because I need a string, JavaScript is working with objects, and the representation is JSON, but this is not the same. JSON is just the string representation. So I have to get a string because later on I need one. And what I also do, I format it a bit nicely so that it looks good. And when I run it on Node.js, and that's above the command how to run it with a small example on Node.js, I get a small JSON document back. And 2 things are interesting here. The score and the positive tokens identified. So there's an algorithm which is able to identify all tokens, to categorize them. I know these tokens I find in the document, and I split them up in positive lists and the negative lists, and this token adds some value and get an overall score. I also have some additional value which is called comparative. This is just something where I use the score and divide it by the number of tokens. In that case, 6 tokens give me a comparative of 1.5. The idea is if I have a short sentence with just 1 positive word, that's better than have just a long sentence with the same positive word. So that's the reason for the comparative. And that's it. So it looks like that's what I want to do. So let's show that quickly live. The first thing here, I hope you can see it. The first thing here, I run it without my wrapper. And what I get back is a default formatting of the JSON object. I see I get the score here 9 and the comparative what I want. The next thing I do, I just run it through my wrapper, and now it is nicely formatted. Looks good. That's for the positive one, score 9 compared to 1.5. I may repeat it also for the negative one. In that case, I get the negative score. So that's basically the idea. Nothing really fancy. But in the end, we are not here to learn Node.js. We want to learn how to do that in the database. So how do I deploy that stuff in the database? And the first version of the MLE came also with command line utilities to simplify that process. dbjs, for example. It's similar to load Java, which is available since 1.8 or something like that, a long time. So to simplify the loading of the stuff. This is not available anymore. The reason why it's not available anymore is because they want to decouple it from the database cycles, database release cycles. They want to deliver it independently, like we have right now with SQL CL or something like that. And the other reason is they want to use the exactly same command line interface for MySQL. So that is the reason. Unfortunately, in the beta, you don't find it anymore. So the steps here are a bit more complicated because I do it manually. The first step is I want to create, of all my JavaScript sources, I need just a single JavaScript. In the browser development, this is already known. You have several tools, Webpack or Browserify, to do that, where you say, yeah, that's my starting point, and then it finds out its dependency and puts everything in a single JavaScript file. That's the analyze bundle I have here. And then I can create or replace JavaScript source and put that output of the previous result there, a large DDL. And that's what I said previously I want to process with SQL CL. SQL Plus is not able to do that because it finds the first semicolon and then I get an error. And the last step is I have to create a PL SQL wrapper to make it run. Exactly the same procedure as we know it from Java. So I have somehow to map to identify what function am I calling. I have to map, this in phrase goes here in this phrase a string, and the return value is a varchar, and here it's mapping to that string here. And this leads us to the question, how many data types are currently supported? And these are just 4. So we have number, binary double, varchar, and date. And that was the reason why I have to convert it to string. In the future release, I'm quite confident to optimize that this conversion shouldn't be necessary anymore. Okay, and then I may use this function in SQL as we know it. Here with a simple example from Dual, or better, the use case I wanted to solve initially. So what I do here is I select it from the router, I use this analyze text to get a JSON document, and then I get out the score and the comparative values based on the JSON functionality available in the database. And then I limit the total results to the top 10 negative results. That's SQL we all know. So that's the result. I just show that step live. First, the deployment. That's the browserify step. I get this analyze browser JS. Let's look at it. Let's look at the size we have here. We have about 4,000 lines of code. Who is interested to convert that to PL SQL? Who would do that? No one? It's on the limit, huh? But you have to maintain it. So, yes, that's one reason. Let's go back. What's also interesting here is that we have some emojis here. They have also some values. And when I can search for awesome, and awesome has 4 points, and perfectly has 3, and like has 2. So you see, JavaScript is easy. So these are the 9 points I get there. So, and the next step, I leave the editor, and then I install the JavaScript into the database, create the wrapper, and I'm ready to run it. So I enhanced the example a bit. The first example just runs the same text, but I added also an emoji to show that it is identified as a positive token. And also the negative one here, this guy here, is identified as in the negative list of the token. So this seems to work. And finally, I run the whole stuff with my query I showed in the slides before and get the top 10 negative ratings. So this is a result out of 900 rows, and you see it just takes half a second, something, oh, you don't see it, half a second to produce the result, so it's quite fast. So that's why it's interesting to do the stuff within the database. By the way, you can get this data from free. These are open data. Good. So now we're coming to stuff which I cannot really show. So when will be this stuff productive, and what will it include? So I really think it will be 20C. It depends on whether they find some critical bugs. It depends on they are ready to call the current API finalized, something like that. But from my point of view, this is good enough to be pushed in the first non-long-term release. So that's why I guess it's 20C. What will be included? Basically, everything we have right now in the beta version. We will also get access to the dbjs via a separate channel, that's clear. But what I haven't mentioned yet is some restrictions which are important. So this restriction here is really, really important. You don't have access from JavaScript or Python to the file system nor to the network. It just does not work. But if you deploy a JavaScript package into the database and it has code which is accessing files or it's accessing network, this works. You just don't have to execute that part of the code. So yeah, it's not that bad as it sounds, but it may be bad if your chosen package is creating some temporary files or something like that, then it won't run. It's important to know, and that's what I think it's important to know on this slide. So this raises a lot of questions. Where are we heading? So one of the first questions I had, how do we deal with a growing language base? So we get more and more languages. Basically everything could run on the GraalVM. Do we get tons of DB tools, DB for whatever language? Or do we get some generic command line or a mixture of it? What will happen with less common languages which are available basically for the GraalVM outside of the database? Will there be a possibility to push everything into the database? What about custom languages? Based on the Truffle framework, it's relatively easy to produce a custom language running on the JVM, something new and fancy, and the update process, obviously. And another interesting question which raises is, how do we deal with existing package managers? When we load a lot of packages into the database, we want to manage it out somehow. And there are already tools to manage that for every language. We have something for the Java ecosystem with Maven Central, what I showed previously with NPM for JavaScript, and so on and so on. So do we have solution for that one in the future? And how do we deal with with usability versus security. When I reference some package known by the package manager, it will be installed automatically with all its dependencies. It may suck up some vulnerabilities into the database. What version or which component have I installed, and how do I update them and get track to? So these are the questions I have in that area. And what are the solutions for languages without a package manager, like PL/SQL, for example? How do we deal with languages which are not browser-viable? So I showed the example with JavaScript. With Python, you could do something similar, but that does not work with Java. You cannot put multiple classes in one file. It does not work yet. And what is the solution there? Is it really necessary when I put in a jar into the database that every single file becomes an object and slows everything down? Will there be a simpler solution in the future? These are the questions. And the most interesting one from my point of view is what happens with the existing languages, with the existing languages like SQL, PL/SQL, and so on. So will they run on top of the GraalVM? Is that possible? Technically, yes, that's no restriction. You have to consider something more. If you do some semantic analysis of a SQL statement or PL/SQL, you have to find out if this table really exists in this schema or view or whatever. Is this column really part of that table, and so on? So for the parsing and compiling, some more information is needed, but technically it's no problem to configure somewhere a default connection for that one. So it could be possible to enable every single language to deal with static SQL. So this leads me to the last set of this presentation. So where are we heading to? I said in the beginning, it doesn't matter if it's version 30 or it's version 32 or 29 or 28. It's the idea direction where we are heading. And this is nothing I gathered as information from somewhere. Oh, that's the plan from Oracle. So that's kind of a personal wish list. Okay. So what I think will happen, or what I think would be a great idea to happen, is that every code within the Oracle database runs on top of the GraalVM. This means the C code we have existing, the existing C code runs on top of the GraalVM, on top of the Truffle framework. We'll have some overhead there. Maybe we get it back somewhere else. Java, of course, SQLs, many dialects are possible, and so on. And you see some fancy stuff here I've written. C#, visualbasic.net, T-SQL. Technically, that's possible. I wish it will work. And we are talking about 10 years in the future. When you think about 10 years in the past, who would have thought that Microsoft will say, we love Linux, and actually we believe it? So in a time frame of 10 years, a lot of things may happen, and if something in that direction will happen, it will, of course, help to push code into the database. The question is, who will see a business use case behind that stuff? So I wish we could enable optional and disable languages and enable also custom languages, DSLs on top of that. And of course, we get all the benefits from the GraalVM, the performance, the no context switch overhead when I'm using additional languages. It doesn't matter in which language something is written. In the end, when it is compiled, all are the same. And I have the possibility to run static SQL from every language in some way. So what I like in PL/SQL, when I compile something, I get an error when I've written something wrong in a SQL statement. I like to have that in JavaScript, in other languages as well. So that's my wish. And technically, it's possible, I think. And then, with that feature, every language becomes a first-class citizen in the database. We have currently just one first-class citizen, and that's PL/SQL. And the acceptance of PL SQL, let's say it this way, is not really growing. Okay, then the next thing is, I think it's a no-brainer. We have controlled access to the file system and network as we have today. And we will probably get something like a universal package installer. So which is an umbrella over all existing package installer, and which is also a solution for stuff without a package installer. Consider, hey, we could use package installer. I do something like install dbpl SQL, install utpl SQL in my SQL database, in my Oracle database. Sounds cool. And we have the ability to use all languages in SQL. It's already possible to use that for Python and JavaScript. You can use the dbms MLE within the with clause as a function and process everything in one SQL segment. I just wish to go a step further and be able to somehow reference packages there, other packages, so they may be sucked in permanently or temporarily, sandboxed way or whatever. And if you think this is all science fiction, then I come to the last slide in this section, which sounds a bit like science fiction, but I think it is not. So I think we get the ability that the JVMs, the Graal JVMs, will be able to talk with each other. So we have our one GraalVM here. This is the database GraalVM. We have one here. This is the outside GraalVM. And they are running on Truffle framework and say, hey, I see we are shipping all this stuff over the network. It would be quite a good idea if I put that code to the database so we have less round trips. Something like that. So optimization, shipping code at runtime. So this will improve the overall runtime. This is something, sounds fancy, but for small use cases, it's doable nowadays already. So I come right now to the conclusion, and I'm really in time, so I'm surprised somehow. Okay. I think the future is bright, and I think really, as I said in the beginning, this MLE has the potential to become the next big thing. It won't be when it stops with the current functionality, but when it really goes in that direction I pointed out, as I said, as 30C, I believe, it will. So we get everything which is cool with the GraalVM in the database, and we have now the option to choose where I want to run the code. There are cases where it's obviously I have to run it on the browser side. It does not make sense to run everything in the database. And there are cases where it's obvious that I have to run it in the database. It becomes difficult in this middle gray area where we have to design and think about, oh, it has some advantages if I run it on the client side. It has some advantages if it runs on the database side. And then you decide, you do it, and maybe later you come back to your decision and shift and move it to the database if you really expect better performance, or during development you may try one thing out and the other thing out because the languages are supported in the database. You don't do it if you have to rewrite the stuff. And in fact, it's a good thing for database-centric development because all languages will become first-class citizens. This is the potential, not only PL SQL. So, and when all this happens, I hope I'm still in business and can do some fancy project. So, and with that, I finish. I'm able to take one question. Yes? Do
you think asynchronous code execution has a place in the database?
Yes. Okay, that was one question. I suggest you come up, talk to me afterwards. I'm here until tomorrow morning, so just reach out. I may show you something on my laptop if you like. And thank you for the attendance. And enjoy the conference.